Hello, good morning. My name is Alba. Last year I finished my master in forest engineering and in data forest. And now I'm going to start my PhD in forest, that is an enterprise that is here in Palencia. But now I'm going to talk about my master thesis that was about enhancing fungal diversity in production through landscape-scale mosaic forest management in Mediterranean ecosystems while reducing fire risk. So, oak forest alternating with cistus shrub are one of the most widespread ecosystems in the Mediterranean region. And to these ecosystems, there is associated a great diversity and fungal richness that can depend on different factors from the environmental and for the vegetation, like the cover or the microclimatic conditions. And between these species, there also appear some species with gastronomic value. It's also known that these shrubs can have a nerve function where they can facilitate the establishment to more advanced stage of succession in oak forests. And it's also known that cistus ladanifer shrubs are high flammable, and this together to the rural depopulation has led in an increase in the extension that is occupied by them, and with it, the increase of the risk of fire. So, to prevent these situations and the economical and environmental costs that they entail, it's important to establish different management measures where at the same time that we can break the continuity of the fuel, we can also help the fungal communities to have a greater production and diversity, so we can also have an extra value in these forests. Because of this, the objective of this work was to analyze the effect of the plot age on the fungal community in terms of production and diversity for mycorrhizal and saprophytic fungi. So this study was located in the province of Zamora, that is in Castilla y León, in the municipality of Rabanales. And inside of Rabanales, the plots are shown as were located as they're shown in the image. In green, the Quercus plots, in purple, young cistus plots, and in red, old cistus plots. So the size of the plots were 2 per 50 meters, and they were established randomly, and then the sporocarps were collected during 4 consecutive years, weekly, from October to December. And then the sporocarps collected were identified and classified by trophic group and edibility. And after this, the data analysis was performed where we measured the sound diversity index, richness, and we use also different statistical methods to test the effect of the type of the vegetation and by species, and also with the age of the vegetation. So after the 4 years, we collected a total of 1,867 sporocarps from 163 taxa, with an annual fresh weight production of 990 kilos per hectare, where they also appear species with gastronomic value. In terms of production, the production was higher in the young cistus shrubs and differs significantly from old cistus and Quercus plots. And this could be because of the vegetation itself, because as it's younger, the cover is closer to the ground, so it might favor different microclimatic conditions where the fructification of the fungi could be better. And in terms of richness, it was bigger and significantly different in cistus plots, than in Quercus. And this could be because the cistus is a pioneer species, so it can be established without any competition. As there is a new habitat, a lot of fungi can be established there also. And then as the succession takes place, the conditions change, and only the fungi that are adapted to the new conditions are able to establish there. And with the diversity, we can see exactly the same trend. Then for the ectomycorrhizal fungi, a higher production was also found in young cistus plots, And we could see also that in the diversity, it was bigger in cistus than in Quercus. And this could be because of a higher photosynthetic rate that can leave a greater amount of carbohydrates available for the fungi. And also, as the succession takes place and the shrubs become older, the growth slows, and also the symbiont fungi that can be maintained becomes also lower. And for the saprophytic fungi, we could see also that the production and the diversity was bigger in Cystus. And this could be because also this higher photosynthetic rate provides a greater amount of organic matter that can be used for the saprophytic fungi to grow. And then the reduction that we can see in Quercus plots could be because we are working with Quercus pyrenaica, that is a Martestan leaf species. So as the leaf does not fall to the ground, the nutrients are not available for the fungi, and when the leaf finally falls, it's very degraded and is not as useful. In the graph that is in the left, we can see that the communities associated to Quercus and to Cystus were different, and the community in Cystus was bigger, so it's important to highlight the importance of the dominant species in the stand. In the second graph, we can see that the Old Cystus community was closer to the Quercus community. So this could be because Cystus can work as a bridge species in Quercus forest, and this could be because of this. And then we can see like there could be a transfer of taxa between the different stages of the succession, where some taxa can only appear in the early stages, others in the late stages, but some of them can be adapted to the different stages. And to conclude, we could see that the productivity and richness of the fungi were influenced by the plot age. Also that this community can stabilize through the forest succession with some transfer of taxa between the early and the late stage. And we could suggest that a forest management that favors a landscape scale mosaic pattern can promote the connectivity between these stages, so we could have more biodiversity, less fire risk, and more profits in rural economies. And thanks for your attention.